I'm Rob de Jeu from the Vrije Universiteit Amsterdam.
I'm Roy Joshua from Ohio State University, Columbus, Ohio.
I'm James Lewis from University of Alberta.
Charles Doran, also from University of Alberta.
Marc Levine, Universität Duisburg-Essen in Essen.
It's actually a quite wide-ranging program. It goes from algebraic K-theory through motivic homology and algebraic cycles on to mathematical physics. And maybe my fellow organizers can say something about those various fields.
Well, the other thing is that it also involves people from different points of view towards the subject. It's very broad, and we learn from each other's differences in how they approach the subject. So regulators, for example, which is basically a map from algebraic cycles or K-theory to some computable homology theory, is approached from various different angles. And the point is that we compare notes, and we understand with the progress of the subject, in fact, evolves around our comparisons.
I'd say exactly. It's nice to have people coming from all these different areas. K-theory itself, when it started back in the 60s and 70s, was sort of a tension between topological methods, homotopy theory, algebraic geometry, and commutative algebra. And this tension between these different viewpoints is maintained in the whole areas of motivic homology, of motivic homotopy theory, ranging all the way to mathematical physics. So I think that's this discourse between people who specialize in various different areas but learn interesting questions from people outside their areas but still have a common language with which they can communicate is a very strong feature of the program.
So this actually is looking at algebraic varieties from a homological point of view, but using different aspects like K-theory is one type of homology theory, motivic homology is another one, and there is a deep interaction between many of these, and one of the main themes of this program is to explore some of these deep connections and interactions between them, and hopefully make progress by doing that.
Yeah, we're also looking to explore the emerging connections between algebraic cycles and mathematical physics, not just string theory, but also now the theory of amplitudes in high energy physics. So we have a two pair of workshops. One is a traditional research workshop, the last workshop of the term, but we also have a satellite event in London aimed mostly at grad students and postdocs, and we're bringing in speakers from all over internationally who are giving a series of lectures to educate the next generation.
Well, in 1998, there was a NATO conference I organized, NATO Advanced Study Institute, where various groups were studying what seemingly was different objects but turned out to be the very same thing. And one thing that comes to mind is the approach to what is called arithmetical variations of power structures, which is a very strong theme at the NATO Institute. And that was the first example of how progress is made, because the imprint of that those points of view resonated with people and ultimately determined their future work.
I was a grad student of it.
Yes, you're my student.
I'm your next door neighbor.
Right. And you have my key.
That's true. So I should just say, in terms of mathematical physics, it's a particularly exciting time. String theory has had an enormous impact on the mathematics of Calabi-Yau varieties ever since its inception. But now the ideas from string theory and the way in which they've shaped the field of Calabi-Yau geometry are beginning to be applied in other places. Within physics, you have applications of string theory ideas to other branches of physics, and within mathematics, Calabi-Yau manifolds are now becoming a tool for computation and a tool for exploration. So we're finding patterns in not just in string theory, but also in the study of amplitudes that suggest an important role for Calabi-Yau geometry, and hence algebraic cycles. So it's a very exciting time. I should
should say that also some decades ago, Vojevodsky did some very important work in algebraic K-theory, and sort of was invented motivic homology, I would say. And well, the reverberations of this is still going on in the field. Some maybe, well, to me, surprising applications in human geometry. So this is still one of the main ingredients in the background of this program too.
Yeah, absolutely. This area, coming from Vojevodsky's work, we'll call it the motivic homotopy theory, goes back to the roots of K-theory, mixing homotopy theory and algebraic geometry. And Vojevodsky had spectacular success with that. I think since his successes, the field went through an internal development, but now it's starting to, having built a lot of the interesting foundations, useful foundations, it's now starting to reach out to other areas in really interesting and effective ways.
I think that in many ways the world of arithmetic geometry and its role as somehow appearing to be the applied mathematics of physics, in a sense, mathematical physics, is something which is an important direction for us to forge ahead with. And as you know, I'm echoing Chuck Doran's comment on the mathematical physics side. We've been fortunate to have places like the Newton Institute to run programs like this. And in fact, I've taken advantage of a lot of institutions around the world where they've fostered the development of interactions between mathematicians sharing their different ideas and moving ahead with them. So I see in the foreseeable future as a challenge is to somehow strengthen the bonds, the initial bonds we have, or links, to form very strong bonds in the future. And so between mathematics and physics, there is still a gulf between the two camps, and we're still trying to learn the language of physics, and physicists are trying to learn the language of mathematics. That's a challenge, but it's a challenge that we'll get over, and we'll move ahead with it. And once we do understand, you will see progress.
And this is one of the reasons why we're focusing our satellite conference with an educational feel. It's still heavily into research, but it's aimed at the large body of students based in and around the London area, who are grad students, who can be introduced to both the math and physics ideas associated with this workshop. We have a series of lectures by mathematicians and by physicists working in teams, so that the sort of pedagogical foundation is there for the students. And then many of these students, and certainly the postdocs, will come up here to Cambridge and the following week participate in the research workshop. So we're really trying to develop the common language in the next generation.
Now the subject of algebraic cycles and motivic homology and K-theory is full of so many deep open problems and questions which have still remain unanswered for many years, and we are hoping that by bringing together experts in all these different areas, we will be able to make an attempt at understanding some of these problems and maybe make progress in trying to solve some of them. Maybe not right now, but maybe as a result of this big program here in the next few years, possibly.
And one broad, maybe technical area, which I hope will be furthered in this program, will be expanding the foundations of what are now motivic homotopy theory to phenomena which are sort of not A1 invariant. So motivic homotopy theory relies on that as the basic structure, but there are many phenomena which don't have this property, which are extremely interesting. And there's developments in this area, but it hasn't really gotten to the point of a real solid theory. And I hope by bringing people in these two different areas together in this program, progress can be made in establishing really good foundations for that extended theory.
Yeah, we believe definitely that is going to be the case, because we were able to attract large number of participants from all over the world. In fact, there are participants from various developing countries. There are a large number of participants from India, from Mexico, from the US, and also working in different areas like in arithmetic geometry to motivic homotopy theory. And because of all of this, we believe that this is going, and also younger generation, we were able to attract a number of graduate students and postdoc researchers. So we believe that we will be this has a big impact on future research.
I think the setup of the Newton Institute is really a perfect setting for reconnecting with treasured colleagues and meeting new ones. So I look forward to that being part of the results of this program, as collaborations arising out of those old and new contexts.
I'm a strong believer in serendipity, discovering things by accident, and maybe not so much by accident, but just collaborations. And big breakthroughs often involve novel types of thinking, new ideas, and we definitely need new ideas in our subject in order to move ahead with the solving some of the pressing conjectures that have been around for, I'd say, at least 50 years. And we can pretend that they're true, and we can operate as if they're true, but we really need to actually prove them. And so that is a very, very, involved, high-level goal, is to try and settle some of these conjectures.
So one of the main goals is really to bring into contact those various fields that have been mentioned already, which is very wide. There's of course some evidence already that there are very useful interactions, but actually the goal of the field is really to foster those and to really generate those those collaborations between the various fields that are present here now and in the future.
Yeah, we've been fortunate. I mean, some of the most senior participants in our program are the most broad-minded in their research outlooks. So the fact that they have that perspective, it trickles down, and you might want to hole up in your office and work on just your subject, but here at the Newton Institute, with that leadership, that won't happen. Everyone's going to be talking about what they're thinking and sharing ideas, and these research connections will happen.